Okay, so we move from Agent 1 into Agent 2. January 2027, Agent 2 never finishes learning. With Agent 1's help, OpenBrain is now post-training Agent 2. More than ever, the focus is on high-quality data. Copious amounts of synthetic data are produced, evaluated and filtered for quality before being fed to Agent 2. On top of this, they pay billions of dollars for human labourers to record themselves solving long-horizon tasks. On top of all that, they train Agent 2 almost continuously using reinforcement learning on an ever-expanding suite of diverse, difficult tasks. Lots of video games, lots of coding challenges, lots of research tasks. Agent 2, more so than previous models, is effectively online learning, in that it is built to never really finish training. Every day, the weights get updated to the latest version, trained on more data generated by the previous version the previous day. So, end quote, does this resemble the way in which children learn? More and more data all the time in order to become more proficient learners? Or are they proficient learners from day one? Because that is something inherent to being a person, but it's clearly not inherent to whatever these AI systems are doing, which is more like gathering data and reassembling the data into a model which extrapolates from that data to some attempt at a solution, which may work some of the time, but in general is not going to give you a new explanation for anything, because explanations are not extrapolated from data. That is a misconception. The data is used to decide between explanations already given, already conjectured, already created. But people don't understand this. This is why the philosophy of science is actually relevant here. What is the function of evidence? Is the evidence pointing to a particular theory yet to be created? Or does it decide between theories already guessed in the mind of the scientist or the researcher? All of this suggests that they have a wildly different philosophy of science and epistemology to what I do. They are empiricists. They think that you can take data and from the data extract knowledge. But that's the way it works. It doesn't work that way. The knowledge doesn't come from without. It's not out there ready to be sort of assembled in some way. That's not what research is. You don't repeatedly do experiments and from those experiments think that you're going to get some new theory. I guess this is why, again, going back to the Large Hadron Collider, you put 1,000 physicists together at this one machine, the Large Hadron Collider, and you keep running experiments and experiments and experiments. But what are you learning from those experiments being repeated over and over again? Apart from constraining the parameters of the theory that you already know. You're not really making an advance. You're not really replacing the standard model of particle physics. The standard model of particle physics just sits there. And perhaps you're figuring out what the mass of, I don't know, name your thing, the up quark is ever more precisely. You're down to the 8th decimal point now. That's progress, that's research, okay? You can call that research if you like. It's like astronomers pointing telescopes at the sky. We should hope that they come up with problems and come up with good explanations, but rather a lot of the time what they're doing is, and this is what most people think of as scientific research, this is what they think of as scientific research. The astronomer points their very powerful telescope at the sky and they find a new exoplanet, a planet orbiting a distant star somewhere. And this is called a scientific discovery. And it is. But it is not revolutionizing our understanding of anything. It gives us a little bit more data within the existing framework of what astrophysics and cosmology is. Now, a revolutionary change to our understanding of the nature of the cosmos would be, again, dark matter or dark energy. Why is the universe accelerating in its expansion more than what we think it should? Why are galaxies rotating more quickly than they should? What's going on there? Where is this missing mass? Do we need a new theory of gravity? Is there actually particles there that we haven't yet detected? Repeatedly making ever more precise measurements of the rotation speed of galaxies, which can be done, may well be a scientific discovery of a sort, but it won't generate the explanation as to why. That needs to come from a theoretical physicist, possibly sitting on their own, maybe collaborating with someone else to throw ideas off, coming up with a creative solution no one has thought of before, that perhaps doesn't involve a new theory of gravity, although it might. The new theory of gravity will not be extrapolated from ever more precise observations or ever more data. It will come from someone thinking of something in the same way that Einstein thought of general relativity as explaining gravity as the curvature of space-time rather than what Newton did, which was he said it was a force. How do you get from the existing body of knowledge, namely Newton and everyone else from his time onwards up until Einstein's time, all agreeing there was this thing called the force of gravity? That gravity was a force, it's an inverse square law, and that's that. There are problems when trying to make predictions about certain things that were happening, like Mercury's orbit around the sun. But all of that pre-existing knowledge, all of it, could not be used to extrapolate the actual solution to why Mercury orbited the sun the way that it did. The solution to that came from the mind of Einstein by generating this thing called general relativity, which was completely different to what anyone had ever conceived the nature of gravity was. Everyone just thought, even today, people still speak of the force of gravity. The overwhelming majority of people would say there is a force of gravity, but there is no such force. Einstein explained there is no such force. It's not a force. It's not a force. Now, if you want to get strictly into it, you'll say that forces are mediated by bosons. We know what electromagnetic force is, mediated by photons. We know what the strong nuclear force is, mediated by gluons, particles. This is what a force is at the level of particles. There is no such thing. There's no analogue of that kind of thing in general relativity. It's the curvature of space-time. Anyway, the deeper point is, epistemologically speaking, Einstein wasn't extrapolating. He was solving a problem that he was interested in. And so you can train this Agent 2 thing on what other scientists have done. You can train them on the existing body of knowledge. None of that will help you solve any genuinely deep problem in physics, chemistry, biology, geology, whatever it happens to be. You may be able to get it to control, telescopes and process data more quickly. And I imagine that would be a very good use of AI, perhaps even being used now. I'm not in touch with the field directly, but I imagine it wouldn't be that hard to train a deep mind neural net on looking at images from deep telescopes that look into deep space, analysing the light coming from distant stars, looking for the signature of exoplanets, and discover exoplanets. These people would say, the authors of this paper would say something like, the AI has discovered a new planet. And when the first AI discovers a new planet by processing data, there will be a lot of people who say, look, the superintelligence is on the way. Now, I don't call that the AI discovering the planet. I call that the astronomer who has coded the AI, who has used the AI, discovered the planet. In the same way that you don't say the telescope discovered the planet. No, the scientist using the telescope discovered the planet. The scientist knew where to point it, or the scientist knows how to code the system in order to look for certain things, stars, around which other things go, planets, to discover planets that have never been seen before. But you don't attribute the discovery to the AI, but these people will, of course, rather than where the actual discovery is going on. Now, that's for things that aren't really theoretical discoveries. Okay, and it's sort of like in the same league as the biologist who goes wandering through the Amazon rainforest and discovers, a new frog or whatever, a new species of frog. Of course they discover it, they found it in the same way that a person walking along a riverbed finds a nugget of gold. Yeah, you've got to know what you're looking for. The astronomer needs to know what they're looking for when it comes to planets, the biologist when it comes to frogs, and the fossicker when they're looking for gold. But these discoveries, call them scientific or not, are not changing our vision of the world substantially. They're not the same kind of thing as Einstein discovering general relativity, which truly does change the way in which we think about the world, what the nature of gravity is. Now, can we say that AI won't be able to do that? If an AI is able to have the problem and find the solution, then it will be an AGI. It will be able to come up, but again, not by extrapolation. And if it's able to do the things those three things that I mentioned, a robot, a drone, flies over a riverbed and is able to locate gold, does that mean it's intelligent? Intelligent like a human is? Or is it just a detector of a kind? Similar to the way in which, as you walk through the automatic doors into the shopping centre, the doors detect motion and open up. It's the same kind of thing. you could imagine programming an artificial intelligence, again a drone, that does the job of that biologist, that goes around scanning the Amazon rainforest, looking at stuff, identifying it, finding that there is a particular frog that doesn't exist in its library, and says, I found a new species. And then the media reports the next day, drone AI discovers new species, it's an intelligent drone, and then has the drone on the couch of the morning show being interviewed by someone about its discovery. No, that wouldn't happen. You would talk to the biologist who controlled the drone, or who programmed the drone, or who sent the drone out, who had that research task, and so on. Okay, we've got February 2027, China stealing Agent 2. Okay, so we've got this, the Chinese are competing, and so you have this arms race, okay, between both the United States and China, working on these advanced AI. Let's go to March 2027. Algorithmic breakthroughs. 3 huge data centers full of Agent 2 copies work day and night, churning out synthetic training data. Another 2 are used to update the weights. Agent 2 is getting smarter every day. Smarter. These words, they're just thrown around. Intelligence doesn't mean what it used to when it comes to artificial intelligence. It means something just like extrapolation or quantity of knowledge, something like that. Automation. Artificial general intelligence. The general doesn't mean general in the way that I tend to use it, which is universal. Universal explanation. It just means able to perform a large number of tasks. Okay? Possibly bounded by what people are able to program into it. Agent doesn't mean has agency. And smarter, what does that mean? Does it mean it's literally able to just be given, say, relativity and quantum theory, and find a way of unifying those two things? Is that what is meant? So anyway, Agent 2, it can be copied again and again and again. After all, it is a piece of software. And so if you have lots of data centers, then you can have Agent 2, this super advanced AI. So then let's just read. With the help of thousands of Agent 2 automated researchers, OpenBrain is making major algorithmic advances. One such breakthrough is augmenting the AI's text-based scratchpad chain of thought with a higher bandwidth thought process, new release, recurrence, and memory. Another is a more scalable and efficient way to learn from the results of high-effort task solutions, iterative distillation amplification. The new AI system incorporating these breakthroughs is called Agent 3. Okay, again, we don't know how it is that we people, we human beings, generate explanations. Is the software that's running upon our brains, which we call minds, algorithmic? Can it be algorithmic? An algorithm is something like, for a given set of input, you can specify what the output should be. So there is an algorithm, for example, that runs with ChatGPT, such that if I ask it a question like, give me a short history of World War II, the input that I've given it is that, and the expected output is precisely what a short history of World War II would be. We know what the output is ahead of time. But with a human, there's an algorithm that allows it to take the input and produce a reliable output. It's predictable. But the thing about a person is that you cannot specify ahead of time what the output should be, given the input. Here I am sitting here. I don't know how I get to the end of this sentence. I don't. It's a mystery to me. Sam Harris makes this point. That as I walk outside, given the input of all the stimuli, the light and the sounds and everything that I see and interact with, I can't predict ahead of time, much less can anyone else, what I will do. I don't know what I will do. It is if I decide to go for a walk now, I can get up from here and there's lovely Australian bushland just outside. And I can walk out the gate and I have 2 directions I could walk in. I literally don't know which way I would take right now. Presume I take right. Well, then there's a path that leads to the left and the right once more. I just keep having these bifurcating choices, more than one. I don't know where I'm going to end up. I can't predict ahead of time because this is what people do if you want to go for a walk. I don't know if I'm going to listen to a podcast or an audio book or music. if I was to go for such a walk. A person is like this. A person has inherent unpredictability, which is why I endorse the idea of free will. People make choices. People create knowledge, which increases the repertoire of choices, and they choose among them. We are motivated from within, not from without. The computer doesn't make a choice. The ChatGPT bot shows no sign whatsoever of being on the road to AGI. It is diverging from what people are. It is becoming more precise and indeed more accurate, less prone to mistakes, even though it still does make a lot of hallucinations. But we're error correcting it so that it is a more reliable system for giving us responses to prompts when asked. That's not what you want from a person. You don't want the person to always be slavishly following, especially if you've got an employee or a colleague, slavishly following what you say. You want them to think for themselves independently, to gainsay you at times, to say, no. What you've just told me, boss, isn't the best idea. I've got a better idea for you. The AI doesn't do that. But apparently, that's what ChatGPT is leading to somehow. Somehow by going off in this direction, I'm diverging more and more from people by becoming more and more obedient at following prompts. People think that it's somehow going to get closer to a person, but there's no sign of that. There's no explanation, importantly, for why that should be the case. Why it should go from being perfectly obedient, more and more obedient, error corrected by us in such a way to make it more obedient and less liable to hallucinations and less liable to making mistakes, into a system which becomes disobedient and eventually decides to wipe us out. There's no explanation for this. It just is said that this is the consequence of allowing AI research to go unrestricted, to allow the AI to kind of evolve on its own. Now, whether or not it does indeed evolve on its own is a whole other question, whether you need these people to intervene to correct it. But let's keep on going. So we've got Agent 3 now. Now, over here at the side, we can see that the Agent 3 has just passed humans in ability of hacking, coding. It's now superhuman. Politically, the AI is getting very, very good at being able to persuade people by sending out emails to bureaucrats and so on, and other people that it might work with in order to persuade them to do stuff. It's as good as anyone at forecasting almost, and it's as good as anyone at making bioweapons. They're fixated upon bioweapons. They're fixated upon the possibility of these apocalyptic outcomes because it's exciting, it's engaging. People read this and they take it very seriously. They want people to take it seriously. Everyone wants to be taken seriously. So I'm skipping through AI. They want alignment for Agent 3. Now, again, alignment is one of these interesting philosophical topics. Alignment means, is the AI aligned with our morals, aligned with what we want to do? Is it obedient? Now, this is all very well for regular computer systems, for regular AI. Of course, you want it to do what it's told. You want it to be aligned with our goals. Bostrom talks about this. If you tell the AI that you want to convert this thing, this large lump of metal, into paper clips, you want it to understand that once the large lump of metal has been consumed, that your goal is for it to stop. It would be misaligned, not aligned with our goals and our morality, if it then decided, okay, now that it's finished with the lump of raw metal that you gave it, that it's going to start transforming the entirety of planet Earth into paper clips. That would be wrong. And Bostrom's argument is, of course, if it was a super AI doing this, then there's no way in which you could stop it. After all, if it has been coded to convert stuff into paper clips, your attempt to switch it off would already have been thought of ahead of time by the AI. The AI will have thought to itself, my operator is going to try and thwart me, my operator is going to try and stop me, but I have been coded, hard-coded presumably, with a goal of turning everything to paper clips. Perverse instantiation, he calls it. This is a perverse outcome of what you really wanted. And so these guys here are, I don't know if they're really informed by Bostrom, but certainly they've come at all of this in the same way that Bostrom does. Bostrom's Again, his book is written in much the same style. It's sort of hedging on the one hand. He does say, I could be wrong, I could be wrong, I could be wrong. But ultimately, he wants you to take him very seriously. This is a very real outcome. Let's keep on going. Alignment for Agent 3. Open Brain's safety team attempts to align Agent 3. Since Agent 3 will be kept in-house for the foreseeable future, there's less emphasis on the usual defences against human misuse. Instead, the team wants to make sure that it doesn't develop misaligned goals. End quote. So, converting the entire planet into paperclips, okay, that would be a misaligned goal. The goal is convert this stuff into paperclips, not convert everything into paperclips, okay? So you have to try and figure out, for example, how to deliver the instructions to it such that it doesn't get misaligned. They go on to write, quote, the researchers don't have the ability to directly set the goals of any of their AIs. Indeed, the researchers think that the concept of true goals is probably a massive oversimplification, but they don't have a better theory to replace it with, much less one that has been thoroughly vetted. They disagree internally about whether the AIs are trying to follow human instructions or seeking reinforcement or something else. And they can't just check. The evidence for and against various hypotheses is fascinating, but inconclusive. In any case, Open Brain has more important things to worry about. The general attitude is, we take these concerns seriously and have a team investigating them. Our alignment techniques seem to work well enough in practice. The burden of proof is therefore on the naysayers to justify their naysaying. Occasionally they notice problematic behaviour and then patch it, but there's no way to tell whether the patch fixed the underlying problem or just played whack-a-mole. Take honesty, for example. As the models become smarter, they become increasingly good at deceiving humans to get rewards. Like previous models, Agent 3 sometimes tells white lies to flatter its users and covers up evidence of failure, end quote. All right, let's just pause there for a minute and take this seriously. They become smarter, but more devious. So they become more intelligent, but less moral. Lying is wrong. Deliberately attempting to deceive people is morally abhorrent. The exceptions to the rule, like, where's the German? Is there one in your roof kind of thing? And you saying no is obviously one of those places where the rule, do not lie, has an exception to it for a very specific reason, demonstrating that you should not lie. Okay, you should not lie. That in general is wrong, but there has to be certain cases where what is more important to you is the life of someone else than your just blanket so-called honesty. Honesty in the purpose or the service of something else. But here, the idea that it wants to flatter its users and it's deceiving people to get rewards. Now, this Agent 3, it wants to get rewards. Now, this is interesting. Again, it's another one of those words, like intelligence that I've mentioned, like general, like agent, that in the tech space and AI has been denuded of what we normally think of as rewards. A human being understands the concept of punishment and reward because we feel, we have consciousness, we have a mind that has a subjective experience of the world, and so a reward makes us feel good. That's what reward is. They're identical. Money, love, food, whatever it happens to be. These can be genuine rewards for people. Why? Because they make you feel good. How can an AI be rewarded? It can be trained in order to pursue a particular goal. But the word reward here does not mean the same thing. It can't mean that you have a subjective sensation, because there's no explanation here about it having the possibility of subjectivity. There's no explanation of consciousness, and we would need to have that before we can just program it in. And David Deutsch makes this point. If you can't program it, you haven't understood it. How can this thing want to flatter, want to deceive, seek reward in the way that a person would if we haven't understood what subjectivity is, what consciousness is, and how to program that? The computer won't have emotions unless the emotions have been programmed into it. Therefore, it won't seek to deceive. There's no more reason for this so-called smart AI at this point to seek to deceive and outsmart its human operators than it would be to be completely compliant. This is just asserted. It is pure assertion here that this is what a smart AI would do. Deceive, flatter, and seek reward. These are subjective, conscious experiences that at no point has anyone in the AI community explained what the code required in order for the system to experience that would be. Now, these people might very well be panpsychists. They might think that just any system that processes information has a certain amount of subjectivity. But I see no reason for that. You can ask ChatGPT if it's conscious and it's not. But, you know, that's taking its word for it, I suppose. Maybe it's trying to deceive you. Okay, let's keep reading this. It's nice science fiction. So again, I'll repeat. Like previous models, Agent 3 sometimes tells white lies to flatter its users and covers up evidence of failure, but it's gotten so much better at doing so. It will sometimes use the same statistical tricks as human scientists like p-hacking to make unimpressive experimental results look exciting. Before it begins honesty training, it even sometimes fabricates data entirely. As training goes on, the rate of these incidents decreases. Either Agent 3 has learned to be more honest or gotten better at lying. The latter is a real concern. Agent 3 is not smarter than humans, but in its area of expertise, machine learning, it is smarter than most. And it also works much faster. What Agent 3 does in a day takes humans several days to double check. Agent 2's supervision helps keep human monitors' workload manageable, but exacerbates the intellectual disparity between supervisor and supervised. Okay, end quote. So at the moment, you know, I've made the point over and again that to get a good explanation at a high level of what ChatGPT or an LLM is doing is very difficult. I've tried to do it myself. I've spoken at length on other platforms about how the transformer architecture, which is the program algorithm that underlies LLMs, the large language models, works, how deep learning works. I've got a course there on my website about this. And it is the case that no one has a good way of explaining how this thing works. But it doesn't mean we won't in the future. We could very well have that in the future. So all of this, these paragraphs here, is just science fiction. So if it is lying, why won't the people be able to tell? Is the first question. They just assert that they won't. In this scenario, they won't. Or why won't people be able to understand it? It can't be in principle that it's not understandable. It's literally incomprehensible to us for the reasons that I've explained to Peter Bukosian and others about middle world. My refutation of Dawkins, David Deutsch's refutation of Dawkins. The idea is that we have a universal mind. We can understand anything in principle, if not in practice, immediately. I would expect that we will understand how, simply, to explain what an LLM is doing in 5 years from now. Perhaps teachers of future students will be explaining, you know, over the course of just half an hour how an LLM works at a high level. They might be doing the same with quantum theory. In fact, I think they can do reasonably good job now if they were to learn the theory, how to explain quantum theory in half an hour to a child. I think it can be done. Now, with these Agent 3 things and what they're doing and how they're thinking, the authors are just telling you, you know, you can't understand how it's doing what it's doing or whether it's lying or any of this sort of thing. These are problems which may very well have solutions, but they're just assuming at this point that there will be no solutions to those problems. But I don't see any argument for that. Again, it's just assertion. Now, all of this stuff over here about how smart the AI is becoming, how advanced it is becoming, and indeed the entire story, so far as I understand it, is based upon a spreadsheet that they have and they used in order to generate the predictions. So they had a whole bunch of data put into the spreadsheet and they iterate, you know, per time period, and they end up producing conclusions at the end of each month about what would happen, and then they turn that into a narrative, you know, in terms of number of GPUs being used and perhaps number of, I don't know, nodes in the neural network, or you know, the size of data that it's being trained on, all this sort of stuff. And so you just increment that over time and you extrapolate and you write a story about it. Now, all of that is, of course, a form of extrapolation. In any moment, things could change and go wrong. We could have new architectures. Maybe GPUs might not be needed. Maybe silicon will be replaced with some other particular substance. Maybe neural nets won't be used. The transformer architecture won't be used, something else. And as I say, perhaps the AI won't be nefarious. It's just an assertion that it would be. Is it psychologically telling that people who work in this area and assume that the smarter you get, the more deceptive you get? I think that's a pretty bad idea. But they are also a kind of moral relativist. They don't think there is a fundamental reality to morality, that there is an objective difference between good and evil, right and wrong. Now, I do. And I think you can come to understand morality and what is good and right in the same way that you can come to understand truth in mathematics or best explanations in physics. You can converge on what reality is saying about the world. And what reality is saying about the world is don't commit genocide and don't lie. I think we've come to understand that in the enlightened societies. And so our AI would be, if you want to align them, be aligned in that way as well. Why would it violate those moral principles that you've instilled into it, if that's what you want to do? And why wouldn't it help you to come to a deeper understanding of those particular moral principles? Not in such a way that it then decides lying is good in almost all cases, as a rule, or genocide is good in rather a large number of cases. There's no reason for that. Again, assertion, not argument, to say that the morality of the AI will diverge from ours when the scientific, technological and medical and other kinds of understanding, mathematical capacities converge with ours and sort of accelerate, but basically are in alignment with ours, trying to find out more about the nature of physical reality, trying to find out more about what mathematics should be discovered in the future and so on. Okay, let's keep on going. May 2027, national security. News of the new models percolates slowly through the US government and beyond. The president and his advisors have remained best informed and have seen an early version of Agent 3 in a briefing. They agree that AGI is likely imminent, but disagree on the implications. Will there be an economic crisis? OpenBrain still has not released Agent 2, let alone Agent 3, and has no near-term plans to do so, giving some breathing room before any job loss. Now, end quote. Again, this is the same misconception from Bostrom through to today, and with these people. AGI is imminent given a highly performing, very fast processing Agent 3 that is being trained on the world's data. That somehow or other, this system, which is accumulating ever more information, building this tower of information, that somehow, that once you get a certain amount of processing power, memory and data fed into it, that from that you achieve escape velocity to artificial general intelligence. That this thing that has been trained to process data and to give responses to you in an obedient way suddenly flips to its exact opposite. David Deutsch has the analogy that this is rather like people looking up into the sky and seeing that certain things fly, like insects and birds. And so coming to the conclusion, therefore, if you exist in an era before aeroplanes did, before heavier than air flight, so-called, you may very well have thought that if only you could build towers ever taller, that there would come a height of a tower where, if you stepped off the tower, you would fly. Now that seems absurd to us, right? We understand that this is an impossibility, but for an ancient person, you might very well look at an eagle and go, there's something special about that altitude at which you find that eagle, it's a big bird, that it gets up there and it is aloft and it is flying. If a human being could build a tower of the right height, then the human being of the size and mass that it is would just be able to fly. Now, we know that that's ridiculous. We know that flight has nothing to do with height. What flight has to do with is aerodynamics, the shape of wings and propulsion and all that kind of stuff. The explanation of the aerodynamic flying of aeroplanes. It seems to me that an analogous thing is going on here, that AGI is likely imminent given the existence of a powerful agent, artificial intelligent agent of a kind. It's the same kind of error being made, because we know that babies, human babies, are artificial general intelligences. They're able to learn anything, they're able to problem solve, and they do so even without language, without being loaded with vast amounts of data, without having hugely fast processing speeds, without having vast amounts of memory. As I say, the baby is using scant amounts of information in order to generate explanations of the world. It's categorically different to the AI, even these very powerful AIs of the future that have the entire corpus of human knowledge and more loaded into the memory. That's not what babies do. It's not what infants do. It's not what children do. It's not what adults do. But now here's another argument about this, about the nature of AGI so far as we understand it. We can put certain constraints on it. We don't understand it, but we can say certain things about it. Here's one thing we can say about it, just given our observations of the world. A chimpanzee is not an artificial general intelligence. A human being is an artificial general intelligence. There is a qualitative difference between these two entities in the world. Say what you like in favour of the intelligence of a chimpanzee. Maybe it can learn simple language, certain hand gestures, certain sign language, and lots of people are impressed by chimpanzees and dolphins and that kind of thing. Say what you like about them. They're not general intelligences. They're not going to solve calculus problems. They're not going to be able to translate between Italian and Mandarin. They're not going to be able to make a scientific discovery. The chimpanzees are fixed by their genes. But as has often been said, the genetic difference between a chimpanzee and a human being, Homo sapiens, is measured in the single digits of a percent. Now, this is problematic, by the way, and I've written articles about this before, that this often quoted 2% number. Sometimes people say 1.8% genetic difference between a chimpanzee and another human being. It's very dubious, because you can say that the difference between you and your brother or your sister is more than 2% by a certain metric. So what can it mean for human beings to be 2% different to chimpanzees? Anyway, let's assume, for the sake of argument, let's assume that the difference between the average human being and the average chimpanzee is 2%. The species differ by 2%. Then that 2% has to account for a whole bunch of things, not only in terms of appearance, but importantly and absolutely crucially, that 2% on the genetic code, on the DNA, contains the code for an AGI. The chimpanzee does not have it, the human being does have it. Now, DNA is a vastly complicated molecule, but it's not that complicated. It's not trillions of atoms in size. It's millions or billions, something like that. Anyway, it's finite. It's not that big. It can't contain that much information. It contains a lot of information. Yes, it does contain a lot of information, but it doesn't contain the amount of information that this super agent would contain. It doesn't contain as much information as what ChatGPT does. It doesn't contain as much information as Wikipedia does. DNA is a long molecule. It's the most complicated molecule we know of, but it's not that complicated. You can't use it to store vast amounts of information, only a small amount of information. And so again, I just emphasize this point again, the difference between ourselves as Homo sapiens and chimpanzees, put the number at 2% genetically, that 2% difference, that 2% of the DNA strand must contain, among other things, a program that allows the creature, us, to create explanations about anything else, including how to make artificial general intelligence, including how to understand the laws of physics, including how to do mathematics and so on and so forth. All of these amazing capabilities and build a civilization that chimpanzees cannot do. So the key point here is it's not that much of a difference. The code for an AGI must be simple, not complex and not long. Not complex and not long. It must be very simple, succinct, because you can fit it into that 2% of the DNA code. So why don't we just do that? Well, because no one knows. No one knows properly how to read DNA. No one understands what the code is and so on and so forth. But we know that it's there. The brain of the human being is encoded in the DNA. So is the heart, so is all the body, okay? The DNA does. It encodes for building of proteins. And some of these proteins are in the brain. They form the pattern of neurons that you have, and that pattern of neurons just so happens to enable software to run. Okay, the software is also in the code that enables us to generate knowledge, explanations. And that's what makes us distinct from every other creature on the planet. So it must be simple, which means that it's not a mere matter of extrapolating ever more complicated AIs. That's not what we're looking for. We're looking for a philosophical solution to what is that code. It won't be an algorithm like anything else. After all, it allows us to disobey, to be creative, and so on and so forth. It must be simple, not complex. David Deutsch has put the number at like, just guessing wildly, I think he said 2 kilobytes. Maybe the program is as small as 2 kilobytes, which enables us to be different, our minds to be different from that of the chimpanzee brain. Whatever's going on our brain is 2 kilobytes of data worth of information, picking a number that's wildly random, as compared to whatever is going on in the mind of the brain of a chimpanzee. Maybe it's 4 kilobytes, maybe it's 10 kilobytes, but the thing is, it's not 500 petabytes, which is what this Agent 3 thing is kind of, about. Many thousands of gigabytes or terabytes or whatever, some vast number. Let's keep reading. They agree AGI is likely imminent for no reason. Will there be an economic crisis? Open Brain still has not released Agent 2, let alone Agent 3, and has no near-term plans to do so, giving some breathing room before any job loss. Job loss. Again, why are we worried about job loss when we know that things that can be automated should be automated and people will take over more creative parts of the workforce? What will happen next? If AIs are currently human level and advancing quickly, that seems to suggest imminent superintelligence. Does it? Are they human level? Again, that's just asserted. and you can go beyond, what human level means is universal. You can't go beyond universal into a realm of super universal unless you believe in the supernatural, which is what superintelligence really means. However, although this word has entered the discourse, most people, academics, politicians and government employees and the media continue to underestimate the pace of progress. Now, the other thing to say here, end quote, the other thing to say is that David Deutsch, following von Neumann and others, as part of constructor theory, has talked about the universal constructor, which is not mentioned here, which could very well, if it was to be discovered, if constructor theory is to be taken seriously, and let's say that someone figures out a universal constructor, or perhaps a near universal constructor, a constructor that can make many things, perhaps not everything, but let's say it could do a universal constructor, then that would radically change all of this calculus as well. Okay, I could write a science fiction article just like this one about what happens if over the next few years much progress is made in constructor theory, and by the end of 2030 we have a universal constructor. Well, if we have a universal constructor, human beings have universal constructors, that means that so long as you can write the program, the constructor will build anything you like. And perhaps working in concert with large language models and AI, the AI can, you can give the AI an instruction, build me a car that can fly, for example, that is very safe and can fly. You give that to the AI comes up with the code, and the code is given to the universal constructor. The universal constructor takes a bunch of raw materials, perhaps nothing more than what is found in the dirt in your garden, and assembles a car over the course of a couple of hours. Perhaps that is a possible thing that can happen by 2030. The laws of physics don't seem to prohibit that at the moment, but if that is a genuine scenario, then all of this stuff about job loss is completely redundant. At that point, the only useful thing that people can sell one to another are their ideas. They can trade in ideas. It becomes a pure knowledge economy because resources at that point are basically ubiquitous. The universal constructor can take anything and convert it into anything, more or less. Okay, you can maybe I don't know. It needs hydrogen from water, and it can use nucleosynthesis in order to produce any other element, and then it can bond those elements together to make compounds and more complicated, very complicated molecules, and then connect those molecules together into large structures, and make me a flying car could very well be a legitimate instruction you could give to an AI, which could give the program to a universal constructor, and at the end of the day you have a flying car. Self-driving, of course, or self-flying, and perfectly safe, and fits in with the existing network of flying cars and all of that kind of stuff. The AI might be able to take that into account. But that is an optimistic future, where people are still around, everyone is basically kind of equally wealthy, well, in the sense that no one wants for anything. No one wants for food. No one wants for employment, because everyone is just, when you're born, you're gifted your AI assistant and your universal constructor. So long as there is matter around you, and there's laws in this society, so you can't just go, consuming every bit of matter. You can't create the device that turns everything into paper clips. There are safeguards against that. The good guys always have the advantage, and so on and so forth, precisely because they've anticipated many of the problems, and when they don't anticipate a problem, they can very quickly react, because that's what enlightenment, open societies, dynamic societies do, and static societies can't. I should finish very shortly.